Welcome to the Planet of Maths channel. In this episode, we will talk about extracting the square root. There are some ways to do it. I'll show you maybe the slower one, but it always works. For this method, some knowledge of prime numbers is necessary. Prime numbers are those that have exactly two divisors. No more, no less. There must be exactly two. The number 1 has only one divisor. The number 1 is divisible by 1 and nothing more. Thus, the number 1 is not a prime number because it has too few divisors. The number 2 is divisible by 1 and by 2, and that is a prime number. 3 is divisible by 1 and 3, and it's also a prime number. 4 is divisible by 1, 2, and 4. So 4 has too many divisors, and this is not a prime number. And so on, we could continue checking. 6 is not a prime number, neither is 8, nor is 9. 10 and 12 are not prime numbers either. 14 and 15. Prime numbers are numbers 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. For most examples, however, these numbers here should suffice. First example, we need to extract the square root of 50. We proceed like this. We take the number 50 and break it down into prime factors. First, I check if 50 is divisible by 2, and 50 is divisible by 2, so here I enter 2. Dividing 50 by 2 equals 25. 25 divided by 2 doesn't work for me anymore. Checking the next number, which is 3, 25 divided by 3 doesn't work either. 25 is divisible by the next prime number, which is 5. So I'm entering a 5 here, and dividing 25 by 5, it gives me a result of 5. And the 5 is also divisible by 5. This gives me 1, and that means that the factorization into prime factors is now complete. And if I have a square root, and this is a root of the second degree, there is an invisible 2 here. I pair the factors up, meaning into pairs. The numbers that have emerged on this side, I look for their pairs. And I have this pair. A 5 with a 5 makes a pair. Multiplying 5 by 5 gives me 25. And this 25 can be square rooted, because we are root finding here. 25 can be square rooted, resulting in 5. That means from these two 5s, we get a square root of 25, which means we get one new 5. From two 5s, one new 5 is born, and I'm giving this new 5 here at the beginning. And the rest, which I couldn't pair up, I put under a square root, meaning this 2. I'm left with the number 2, and I put it under a square root. It come out to be 5 square roots of 2. That's the result. Example B, the square root of 48. We take the number 48 again, and we factor it into prime factors. We look at 48 to see if it divides by 2. 48 is divisible by 2, so I'm writing a 2 here and dividing 48 by 2, which is 24. 24 will keep dividing by this 2, so I add another 2, and I get 12 from that. 12 keeps dividing by 2, so add another 2, making 6. 6 divides by 2 as well, making 3. 3 only divides by 3, resulting in 1. And that's the end of this prime factorization. Now we look for pairs. We have pairs here. These two 2's make a pair, and these two 2's make another pair. From this pair, a new 2 is formed, and from that pair, another new 2 is formed. We don't have more pairs, so now we have to multiply the numbers we got. Since there are 2 such new numbers, multiply them. 2 times 2 equals 4, and we put the 4 in front. And we write under the root what didn't pair up here, couldn't pair up this 3. That's why I put the number 3 under the root. End of example B. Example C, the square root of 140. We do the same, take the number 140, draw a line, and divide. What does 140 divide by? Start with 2. 140 divides by 2. This is 70. 70 can also be divided by 2. 70 divided by 2 is 35. And 35 divided by 2 doesn't work, so I take the next number, which is 3. But 35 divided by 3 doesn't work, so 3 can't be it. I'm checking the next one. Now a 5? Can 35 be divided by 5? Yes, it can, so we put a 5 here. And dividing 35 by 5 gives us 7. 7 doesn't divide by 5, it only divides by 7. 7 divided by 7 equals 1. The prime factorization is done, so now we look for matching numbers on this side. And we can find them. Here we have 2 identical 2's. From these 2's, we get a brand new 2, No more pairs to be found here. Therefore, we put the number 2 in front of the square root. Under the root, we need to include everything that didn't pair up. Here, the 5 and 7 didn't manage to pair, and we need to multiply these two numbers together. 5 times 7 equals 35. We place this number under a square root. End of example C. Now example D, the cube root of 54. Third-degree roots work exactly the same way, at least initially. We also need to break down the number 54 into its prime factors. Just like before, first we check 54 by 2. Divided by 2, so here is 2. 54 divided by 2 is 27. 27 is not divisible by 2, but it is divisible by 3. 27 divided by 3 equals 9. 9 by 3 also divides, resulting in 3, and 3 divided by 3 gives 1. We reach the end of the prime factorization, and now we combine, but we do not pair up this time since it involves a cube root. So we need to connect them into 3's, and we have 3 identical 3's right there. 3 identical numbers, we combine them together, and from this emerges one new such number, that is brand new 3. I don't have more 3's here, hence these 3. I put it in front of the root, then there is the cube root. And under the root, I put what I couldn't combine into a 3, which is everything except those 3 3's, and all that in this case is just the number 2. So I have 3 cube roots of 2. Example E is yet another example of the cube root of 72. So we take 72 and factor it into its prime factors. Step by step we go. Check if it's divisible by 2. It's divisible by 2. 72 divided by 2 is 36. 36 still divides by 2, so I enter a 2 here and divide, which gives me 18. 18 keeps dividing by 2, so another 2. 18 by 2 is 9. 9 divided by 2 does not divide. Next in line is 3. 9 divided by 3 does divide. From this, I get 3. 3 is only divisible by 3. From this, I get 1. End of the prime factorization. And now reading off. The root is of the third degree, so I look for 3 of the same numbers. Here are 3 2's. I combine these 3 2's into a new 2, and this 2 goes to the beginning, in front of the root. Under the root, I add the remainder that was left to me, and what's left? Besides those 3 2's, I have 3 and 3. I have to multiply these 3's together here. 3 times 3 equals 9. So I got 2 cube roots of 9. And here we have another example F, the square root of 30, so we take the number 30. We're factoring into primes. 30 is divisible by 2, so I enter 2 and divide. 30 by 2 is 15. 15 doesn't divide by 2. Next in line is 3. 15 by 3. It's divisible, and from this I get 5. 5 doesn't divide by 3, 5 only divides by 5, and from that I get 1. So I have the prime factorization here. The root is of the second degree, so I'm looking for pairs, but I don't have any pairs here. What in such a case? In such a case, you simply can't do anything with this square root of 30. The square root of 30 is simply the square root of 30, and that's it. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Mass channel.